Today I want to talk about functions. This is something you should be familiar with from an Algebra 1 course, but I want to highlight some of the important aspects as we move on into this course. So first of all, a relation. A relation is a rule which relates elements from one set to elements from another. So it's just making some kind of an association with elements from one set to another. If it happens that each element in the first set, which is referred to as the domain, maps to a unique element of the second set, which we refer to as the range, then that relation is called a function. So a function is a particular kind of relation, or a special type of relation in mathematics. The easiest way is to look at some examples to understand this. There's a few ways we can represent relations and therefore functions. One of the ways is by a mapping. So in this example, we've got elements from the green set, and those represent the domain of this function. And then we have the elements of the other set, the black set, and those represent the range of this function. And so you can see that each element in the domain, A for example, gets mapped to 1. And it doesn't get mapped to any other number in here. So that's a unique element that it's mapped to. F is getting mapped to 6. T is getting mapped to 20. And N is getting mapped to 14. And finally, C gets mapped to 3. And so each of those elements in the domain are getting mapped to one unique element in the range, not more than one element. So this is a function. Another representation we can use for relations and functions would be a table. And that's fairly common. You'll see lots of tables in mathematics and outside mathematics. So in this table, it's the same mapping. The letter A gets mapped to 1, C gets mapped to 3, F to 6, N to 14, and T to 20. Notice A gets mapped to 1, but A doesn't show up anywhere else. So A is not getting mapped to any other number in the range. Likewise for C and for F and N and T. So nothing here in my domain, the first row, is appearing more than once or getting mapped to more than one element in the range. So therefore that's also a function. Another representation would be a set of ordered pairs. And that would look something like this. Notice I'm using the same mappings here. So for a set, we use these braces, beginning and the end. And then this set contains elements which happen to be ordered pairs. And ordered pairs are bounded by parentheses here with a comma in between the two elements. So this element in the set is the ordered pair A, 1, which tells me A gets mapped to 1, C gets mapped to 3, etc. Notice A doesn't show up more than once. T doesn't show up more than once. None of these letters show up more than once. So each one's getting mapped to a unique element in the range. So that's also a function. So all of these examples are relations, and they all happen to be functions because they satisfy that definition of a function. Other forms, which we'll get into, an equation is a relation, and it could represent a function, and a graph also is a relation that might represent a function. All right, so let's look at some examples of relations and decide, are they functions? Here's a mapping. Is every element of the domain getting mapped to a unique element in the range? And the answer to that is yes. 1 gets mapped to 4 and nothing else. 2 gets mapped to 4 and nothing else. It doesn't matter that 1 and 2 are both getting mapped to the same number. They're only getting mapped to one number, and that's okay. So they don't have to go to separate numbers. So these all don't have to be different. Actually, I could just have 4 here, and all of these are getting mapped to 4. That's fine. As long as none of these elements in the domain are getting mapped to more than one number in the range. So this one, yes, is a function. All right, how about this mapping? We can see that 5 is getting mapped to 20, but it's also getting mapped to 18, so that's a problem. So this relation is not a function because 5 in the domain is not getting mapped to one unique element in the range. It's getting mapped to two different elements. The 6 is fine and the 7 is fine. Those are both getting mapped to one unique element, but not the 5. So this is not a function. How about this table here? Whoops. 1 is getting mapped to 2. Negative 2 is getting mapped to 5, 4 to 17, 5 to 26, 0 to 1, and 2 to 5. Is this a function? Well, 1 is only getting mapped to one particular number in the range. 1 doesn't show up anywhere else here in my domain, so it's only getting mapped to one unique element. And likewise, each of these other elements in the domain are getting mapped to only one element in the range. It doesn't matter that negative 2 gets mapped to 5 and positive 2 also gets mapped to 5. That's okay. I just can't have positive 2 going to two different values. So I can't have any repetition here in my domain. So this one is a function. By the way, you figured out where I came up with these numbers? Did I do some type of special rule? I'll leave that up to you. All right, let's look at a graph. On this graph, this represents a relation. We have ordered pairs. We could write down ordered pairs. These would be the x values, these are the y values. So this first point here, I could think of it as negative 2 comma 5. And I could write all the ordered pairs here. And it might be easier to decide if it's a function or not if you look at the ordered pairs. Or you could put them in a table. Might be easier as well. But once you get the hang of it, you can see that the x value of negative 2 only goes to one y value. The x value of 0 only goes to one y value. The x value of 1 just goes to y equal 2. But we have a problem here. The x value of 2 gets mapped to 3 for y, but it also gets mapped to 5. So we have a point here, 2 comma 3, but we also have a point 2 comma 5. So here we have the element in my domain 2 is not getting mapped to a unique number. It's getting mapped to two different numbers. So this is not a function. You might remember from Algebra 1 that in order for a graph to be a function, it has to pass the vertical line test, which means if you can draw a vertical line that hits the graph in more than one point, like it does here, then it's not a function. And then finally, we have an equation. And is this represent a function, or is it just a relation? Well, I guess we could graph this and then analyze it like we did the last problem. So that's one option. And hopefully you remember what the 1 over x graph looks like. Looks like that and that. And then the plus 2, well, that just shifts my graph up 2 units. So it looks like that. Now, can you draw a vertical line through this graph that hits it in more than one point? And the answer to that is no. It's not the best vertical line. But any vertical line you draw is only going to hit this graph in exactly one point. And if you draw the x equals 0 line, that won't hit the graph anywhere because it's undefined, because you can't divide by 0. So that would tell me that, no, this is not a function. But we don't even have to graph it to analyze that. You can think of it this way. Here's my variable x. That's in the domain, whatever value I plug in there. All possible values of x represent the domain. And then after I evaluate this expression with a particular x value, I get a y value, and that represents a number in the range. So can you think of any number you would plug in for x and then evaluate this expression and get two different answers? And the answer to that is obviously no. For example, if I plugged in the number 3 for x, I'd get 1 over 3 plus 2, which gives me 2 1/3 or 7/3. So 3 gets mapped to 7/3. in this relation. Okay. So, and I don't know why I wrote the word no. So yes, this is a function. It passes the vertical line test. The vertical line cannot hit this in more than one point. So you pick any value for x. I don't know, pick a negative one. How about -4? If I plug in -4 and I do -1/4 plus 2, that would give me 1 3/4. So -4 gets mapped to 1 3/4 or 7/4. And that's one unique element. So no matter what number you plug in for x, when you evaluate this expression here, you'll get one unique value for y. So there's a function. Let's look at two other equations. And I'd like you to determine, do these equations represent y as a function of x? So the first one, we have x squared plus y equal 1. Well, can we rearrange this equation and solve for y? Sure, we could subtract x squared from both sides. And that's what we would get. Now you can think about the graph of that, and we'll talk more about graphing particular functions. But you might remember that this is going to be a parabola opening downward and then shifted up 1. And that would pass the vertical line test. But without thinking of the graph, just think about plugging in a value for x. Can you think of any number that you could plug in for x so that when you evaluate this expression, you get more than one possible answer? And the answer to that is no. So this indeed is a function. Let's look at the next one. Can we solve that for y? Well, we would subtract x from both sides, try and get the y by itself. And then it's y squared, so I would have to take the square root of both sides. And what's the square root of y squared? You probably just said to yourself y, and that's incorrect, unless you were asking why. But it turns out that the square root of y squared is the absolute value of y. And that equals the square root of -x plus 1. Let me do a little side note on that. So for example, what's the square root of, let's say, 7 squared? Well, the answer is 7, because the square root of 49 is 7. What's the square root of -7 squared? Well, -7 squared is positive 49, and the square root of that is also 7. So the answer to that happened to be the absolute value of -7. And the answer to this one was the absolute value of 7. So when we do the square root of something squared, our answer is going to be the absolute value of whatever was squared. Because we want to make sure that we get a non-negative answer. Because this square root symbol represents the positive root, although it could also equal 0. So it's never going to be a negative answer until we get into imaginary numbers, which is later on. All right, so going back to this, another way of writing this then would be y equal plus or minus the square root of -x plus 1.